Hey guys, you are with the Tech Science. Today we have a new point for discussion and the name of the point is extraction of aluminium. In the last video we have the same point, extraction of aluminium, but we are using a Bayer's method for the extraction of aluminium, and here we are using a Hall's process. This is what a new things for us. That's why I upload the separate video for the Bayer's process as well as the Hall's process. The today's point of discussion is extraction of aluminium using the Hall's process. And as we discussed that the aluminium is extracted for the 10th standard. This is the chapter called metallurgy. In this metallurgy we have this point, extraction of the metal. As an example we consider as the aluminium. And this aluminium is extracted from its ore. It is called as the bauxite, as we know that. And this bauxite having the molecular formula bauxite, and this bauxite having the molecular formula Al2O3.NH2O, and we have to extract the aluminum from this. As we know that extraction of aluminium is done in two different ways. We have two different steps we have. The first step, it is called concentration of bauxite ore. Concentration of bauxite ore. And second we have electrolytic reduction of alumina. Second process we have electrolytic reduction. So what we did exactly in the concentration of bauxite ore, we have the two different steps are there. The first is called Bayer's process and second we have the Hall's process. We already discussed the Bayer's process. Today we have the new point for the discussion, that the how to extract the alumina. This is what the output of the first step. Concentration of bauxite ore, we have the input is bauxite and output is alumina. But today's discussion is based on the Hall's process. So this is what the today's point. And this alumina further it is the input for second process, second step. It is called electrolytic reduction of what is the input? Alumina is the input here. And from this alumina we found aluminium is our final aim or our final output. Okay, so this is what actually the chart. How extraction of aluminium is done? Extraction of aluminium is done in two different steps are there, or we can say that it is a process. First is called concentration of bauxite ore, second is called electrolytic reduction. In the concentration of bauxite ore, what is the aim? From the bauxite ore we got alumina from this first process. It is called first stage. It is called concentration of bauxite ore, and it can be done using either the Bayer's or Hall process. Bayer's process already uploaded the video day before yesterday. Now it's time to upload the Hall's process, and in the Hall's process bauxite is the input and alumina is the output. How that we done right now we have to see. Now after getting an output and alumina, now this alumina is the input for the second step. It is called electrolytic reduction, and using this electrolytic reduction process, the alumina from this we got aluminium is a final output. Okay, so this is what the today's point of discussion. Now let's see the first point, concentration of bauxite ore using the Hall's process. So what exactly we did? Very simple process. I will write a chart for you, and this chart will be very useful for us to remember what is the steps to extract the alumina from the bauxite using the Hall's process. So let's start with the Hall's process. Before that, I told you, whenever you got a bauxite from the earth crust, now it's time to filter it, to separate the gangue particles, that is we call it the impurities, from the bauxite. That's why the next process will be somewhat easy for us, and for this reason we are using the different types of methods are there for the separation of the gangue particles from the main ore. And for the reason, as I told you yesterday also, okay, in the Bayer's process video, that we have the gravitational method for the separation, we have the magnetic separation method, we have the different types of method. One more method for is called leaching process. So here also we apply the leaching process, and in this leaching process we are adding. What is leaching process exactly? Leaching process is nothing but the ore which should be soluble in some case of with some liquid, with some we can say that solutions are there, and in that it is completely soluble. So what happened here? For example, bauxite ore. Suppose your Hall's process, what Hall did exactly? So Hall used leaching process along with sodium carbonate, and he used this solution for the bauxite and he soak the bauxite in a sodium carbonate solution for some time. Now what happened here? The aluminium which is in bauxite, it get completely dissolved in this. And but the one thing which is not dissolved, that is what? The gangue particles. This gangue particle does not dissolve in this solution. Automatically they get filtered out. They get separated with the help of a simple any filtration method. That's why we are applying the leaching process. So this is what actually the things what the Hall did exactly in the separation of such gangue particles with the help of some kind of solution. Bayer uses caustic soda, where the Halls use the sodium carbonate. Okay, so for the reason what we did, we exactly extract the alumina from the bauxite within 3 steps. What are these? Observe. First of all, we take out the bauxite. First of all, now this bauxite we are using a ball mill. We grind it and we convert it to the powdered format. This is what the powdered bauxite. Now this powdered bauxite we add with sodium carbonate. That is called leaching process. What is called? It is called leaching process. Means just you have to heat in a digester with this solution. That is called sodium carbonate. And here you found out the final output is what? It is called sodium aluminate. This is the first step. This is the first step in case of the Halls. Now take out the sodium aluminate here, and this sodium aluminate you have to next warm with water and pass the carbon dioxide gas through this solution along with the water. Now what happened here? The final output you got, it is what? Aluminium hydroxide. What you got? AlOH3. That is what the molecular formula. Aluminum hydroxide you got. And further, this aluminum hydroxide you have to use, like you can dry, you can wash, you can filter, and you can apply the calcination process, means heating up to the 1000 degrees Celsius, and finally you got alumina as an output. This is what exactly the first point. It is called concentration of bauxite ore using the Hall's process. So again I am repeating. First of all, you have to take bauxite, use a ball mill to convert it to the powder format, apply the leaching process in a digester by heating it with the sodium carbonate. You got an output as a sodium aluminate. Further, take the sodium aluminate along with the water for the warm and apply and pass out the carbon dioxide gas in it. You got aluminum hydroxide as output. This aluminum hydroxide further wash, filter, dry, etc. and apply the calcination process, means heating up to the 1000 degrees Celsius, and you finally got the alumina. This is what the steps in the first process, that is called concentration of bauxite ore using the Hall's process. Understood? Now let's see the reactions of all this. For example, how powdered bauxite react with the sodium carbonate, what sodium aluminate form, what is the molecular formula. Now further sodium aluminate, what is the chemical reaction? Observe. This is what the first chemical reaction. What? Powdered bauxite react with sodium carbonate, form sodium aluminate. Second reaction, sodium aluminate along with the water and carbon dioxide, you got aluminum hydroxide. This is the second reaction. And aluminum hydroxide, further apply the different types of processes along with the calcination, you got the alumina is the final output. This is the third chemical reaction. Okay, now it's time to see the different chemical reactions exactly in the first stage with the help of the Hall's process. Okay. So without wasting of time, I am writing the 3 reactions what I told you just before this erasing of the blackboard, content of this blackboard. Okay, so here what is this Al2O3.2H2O? It is a powdered bauxite. Am I right? It is a powdered bauxite. And here it is what? The sodium carbonate we have, and we just heat it in a digester, and you got an aqueous solution of sodium aluminate. Just I told you the first output is sodium aluminate along with the liberation of carbon dioxide gas and liquid get formed. Now this sodium aluminate, this is the second step. Now further, this is sodium aluminate you have to warmed with water along with the passing CO2 gas in it. What happened here? Aluminium hydroxide has been formed. Aluminium hydroxide. This is what? Al AlOH3, aluminum hydroxide has been formed. This is the AlOH3, the formula for that. And further, this aluminum hydroxide, when you dry, filter, wash and apply the calcination process, you got, this is the output, main output for us. What you got? You got alumina as an output. So these are the three reactions. Number one, Al2O3 dot 2S2O react with the inactive CO3. Main product is NaAlOT, along with liberation of carbon dioxide gas and formation of liquid. That is called water. Sorry, it is in liquid form. Okay, so this is sodium aluminate. Further, sodium aluminate is the input, and by passing like a CO2 gas with the mixing of this water, what happened here? Aluminum hydroxide has been formed. And further, this aluminum hydroxide, you have to apply the process of drying, washing, filtration, we have the calcination process. Finally, you got alumina is the output. Okay, now this is what the first stage, that is called, as I told you, this extraction of aluminum is done in two ways. First is called concentration of bauxite ore, and finally this is what is the output? Alumina is the output. So this was the first step along with this chemical reaction. Now it's for the second time. What we did now? We have to do electrolytic reduction, and for this reduction we have aluminum as an output. Now let's see the second stage, that is called electrolytic reduction of alumina. And in the electrolytic reduction of alumina, we have a well labeled diagram for that. Now let's see the second step, how electrolytic reduction alumina results into the formation of aluminium as a pure metal. Okay, this is what the second step. This is called electrolytic reduction of alumina. Here there is a diagram. A steel tank. Inside inner lining of this steel tank, we have a layer of graphite, and it works as a cathode. Why? Because it is connected to negative terminal of the battery. There are three graphite rods are there, and they are work as an anode because they are connected to the positive terminal of the battery. And the molten alumina we are taken here, and molten alumina having the melting point greater than 2000 degrees Celsius. So if you have to reduce it up to the 1000 degrees Celsius, we can add the cryolite and fluorspar along with the alumina, and this is what the mixture. So the alumina mixture contains the cryolite and fluorspar. What is the purpose of adding these two? So you have to reduce the melting point of the alumina from 2000 to 1000 degrees Celsius. And it is just, I told you, cathode and anodes are connected with the help of this battery. On passing the electric current, now what happen here? Of course, some kind of reactions occur. What kind of reaction we have? We have the reaction at the anode region and reaction at the cathode region. Anode region, nothing but the terminal of the battery, which is called plus terminal. That region is connected towards that is called anode. And those things which are connected to negative terminal of the battery, they work as a cathode. So on passing electric current, what happen here? The molten aluminium, which is in liquid state, it is deposited near the cathode. As this aluminium is heavier than the electrolyte, that's why it collected at the bottom, and finally with the help of this outlet we collect it, and this is what you got, the pure aluminium. So exactly during this electrolysis process, what happened here? After passing electric current, an oxygen gas get liberated towards the anode, and at the cathode region the reduction reactions occurs and the aluminum gets collected near to the cathode. Okay, so here finally, because of this heavierness property of this aluminum as compared to the electrolyte, finally it will be collected at the base region, and through this outlet we collected the aluminum. So this is what a complete procedure. In a second stage we have the electrolytic reduction. So extraction of aluminum we completed in two different stages. Number one, concentration of bauxite ore. In that case, input is bauxite, output is alumina. And second step we have electrolytic reduction, in which alumina is a input and aluminium is a output. So here you got aluminium is in liquid state and you collected at the bottom side through this outlet. Okay, so this is what a complete Hawes process, starting with from concentration of bauxite ore and ended at the electrolytic reduction. I hope you like my video. If you like the video, please subscribe my channel and press on the bell icon for the new notification. Thank you. Have a nice day.